In this video, I'm going to show you how to graph a quadratic function. A quadratic function is anything that's in the format of y equals x squared. This is the parent function. So for the first one, I'm going to show you a table of values. Normally, you wouldn't make a table of values. You need to learn the parent function and how the h, the k, and the a value all affect it. So if y is equal to x squared, and I make a table, and I put in 0 for x, then y is also going to be 0 because 0 squared. 1 for x means y is 1. That's 1 squared. If x is 2, y is 4 because 2 squared is 4. If x is 3, y is 9, 4, 16, and 5 is 25. So for the y is whatever x is squared. So to plot those points would be the same thing for positive x's and negative x's. So the first thing you do is you plot 0, 0. And then from that point, if the x is 1, the y is also 1. If the x is 2, the y is 4. So you go up 4 spaces. And if the x is 3, the y is 9. The next one is 16. It doesn't fit on the graph. It is a reflective or a symmetric graph. So if you were using -1 for x, the y would still be 1. If you were using -2, it'd still be 4, -3, 9, and so on. So on the opposite side, the points are exactly the same places on the negative side of the vertex. So if I go left 2, I still go up 4, because that's what -2 squared is. And if I go left 3 from the vertex, I still go up 9. In order to graph it, connect those, try to make it rounded at the bottom. And that's the parent function. You need to learn that one so that you're very comfortable with graphing that. Now I'm going to show you how to change this graph based on the hk and the a value. So in this graph, the a value is -1/2. That's this value. The h and the k are -2, 5. So the h value is the opposite of this number. Okay, so the h value is -2, and the k value is 5, the number that's not in the parentheses, that's added on at the end. This is your vertex. That vertex, -2, 5, is going to be the vertex of your parabola, but it's also what you can think of as your new xy axis, if you will. So when you go to graph this equation, you're not graphing all of that. If you were to make an xy chart, it would just be your x values and then -1/2 x squared. You forget about the h and the k. You basically take them out. And so I can make a table, but what this means is -1/2 is that all of the up values are going to be half as much as we did in the first problem. So half as much as these numbers. The negative part of the 1/2 means it's going to be half of these, but it's also going to be facing downward because the a is negative. So I'll make a table afterwards, but I just want to go ahead and go to the graph so you can see what's happening. So here's the vertex. Normally on the x, if x is 1 and you square it, it would be up 1, but I have to take half of 1, and so it's going to be -1/2 times 1 times the x squared. I'll write the x squared here. If it was 2, it would be -1/2 times 4, because that's what 2 squared is. If it was 3, it would be -1/2 times 9, 4, -1/2 times 16. Your x squared are these numbers, and your a are these numbers. So a gets multiplied by the 1, 4, 9, and 16. It's always 1, 4, 9, and 16. So these are your y values. So that would be -1/2, -2, -4.5, and -8. These are your new y values. Again, we're using this as my new origin, where the vertex is. Okay, so that's this number. So from that number, we're going to go right one and down a half, because that's half of the one that we normally would, and it's symmetric on both sides. Normally with 2, it'd be 2 squared, which is 4. Half of 4 is 2, and it's going downward, so you count 1, 2. Same thing on the other side, left 2, down 2. For number 3, which is this one, from the vertex, you go over 3. 3 squared is 9, but we have to multiply that by negative 1/2, which means I'm going down 4.5. 1, 2, 3, 4, and 1/2. Same thing on the other side. And then for 4, 1, 2, 3, 4. 4 squared is 16. You always square it, and then you multiply it by a. So half of 16 is 8. So I'm going down 8 from this point. 1, 2, 3, 4, 5, 6, 7, 8. And that would be here on this side. If I were going to the next number, 5 squared, 1, 2, 3, 4, 5 is 25. 25 divided by 2 is 12.5. I just don't have room to put that. 9, 10, 11, 12.5 would be down here somewhere. So then we can go ahead and graph that. Okay, again, the standard parabola is this one, the parent function. That parent function from the vertex, over 1, up 1. If I go from the vertex, if I go over 2, I would be going up 4. From the vertex, if I went over 3, I would be going up 9. So that's my normal parabola. The a value gets multiplied by those numbers, and that's why this one is upside down. I'm going to do these 2 other problems. For this problem, the a value is 2. That means it's going to be twice as tall as it normally is. The vertex is 2, negative 3, and those numbers come from here. So I'm going to go to point 2, negative 3. Okay, and then if you ignore the h and the k, then the y is equal to 2x squared, which you basically got rid of this number and got rid of that number. Okay, so that means that my normal parabola, again, 1, 2, 3, so x squared would be 149, but because I have this 2 in front, I have to multiply those all by 2. So my up values become 2, 8, and 18. Okay, the y values. Again, we're starting here at the vertex, thinking of it as your new origin. So from the vertex, I'm going to go right 1, and I'm going to go 1 squared times 2. From the vertex, right 2. 2 squared is 4. 4 times 2 is 8, so I'm going to go 8 from the 3, and that puts me up here. Same thing on the other side. It's symmetric. Okay, and then we'll draw that in. I don't have room for the next point. So the parabola goes like this. This means it's twice the height of the parent function. The x values stay the same. They're always 1 over 1, and it's 2, and it's 3 from the origin, okay? Or from the vertex, I should say, okay? So you can think of this kind of like as your 1, 2, 3, but we don't change the x